Speed bumps are one of those things everyone has an opinion about, usually a negative one. They feel aggressive, uncomfortable, sometimes even annoying, especially when you're driving slowly and they still jolt the car. That reaction is exactly why they exist. Speed bumps are not designed to be comfortable. They are designed to change behavior, not inform it. And once you understand how they're engineered and where they're placed, the way they feel starts to make a lot more sense. Most road safety tools work by giving drivers information: speed limit signs, lane markings, warning signals. All assume that drivers will see them, understand them, and voluntarily change behavior. Speed bumps work differently. They don't ask for cooperation. They create a physical consequence that happens whether you're paying attention or not. That makes them one of the few traffic control devices that function even when human behavior is inconsistent. The first important thing to understand is that speed bumps are not all the same. What most people casually call a speed bump actually falls into several different categories, each with a different purpose. Traditional speed bumps are short and abrupt, usually only a few feet long, with a steep rise and fall. Speed humps are longer and smoother, stretching across more of the roadway. Speed tables are even longer, often flat on top, sometimes designed to double as crosswalks. Each one produces a different physical response in a vehicle, and that response is intentional. The aggressive feeling comes from how a vehicle's suspension reacts to vertical acceleration. When a car hits a sharp bump, the suspension compresses quickly, transferring force into the cabin. At higher speeds, that force increases dramatically. Designers use this relationship deliberately. A bump that feels mildly uncomfortable at 10 miles per hour becomes sharply unpleasant at 20. That steep increase is what discourages speeding. It creates a narrow band of comfort that aligns closely with the target speed. This is why speed bumps often feel harsh even when you think you're already driving slowly. They're not tuned for comfort at the posted speed limit. They're tuned for discomfort above it. In many cases, the ideal comfort speed is actually lower than the sign suggests. That mismatch is intentional. It builds in a margin of safety, especially in areas where pedestrians, children, or cyclists are present. Placement matters just as much as shape. Speed bumps are rarely used on major roads or highways because they would disrupt traffic flow, emergency response, and vehicle control. Instead, they're placed in environments where reducing speed is more important than maintaining throughput. Parking lots, school zones, residential streets, private roads, and hospital campuses are common examples. In these spaces, even small increases in speed significantly raise the risk of injury. There's a well-documented relationship between vehicle speed and pedestrian survival. A collision at 20 miles per hour is far more survivable than one at 30. Speed bumps don't need to stop accidents entirely to be effective. They only need to shift average speeds downward by a small amount to dramatically reduce harm. From a design perspective, discomfort is a reasonable trade-off when the alternative is higher injury risk. Another reason speed bumps feel aggressive is that they don't adapt. Unlike traffic lights or dynamic signs, a speed bump doesn't know who you are or how carefully you're driving. It treats everyone the same. That consistency is actually a feature. It removes judgment calls and enforcement gaps. There's no need for police presence, cameras, or citations. The system enforces itself through physics. This self-enforcing nature is also why speed bumps persist, even though many drivers dislike them. Studies consistently show that they reduce average speeds, and cut down on dangerous driving behaviors like shortcutting through neighborhoods. Even drivers who complain about them still slow down, which is the metric that matters most. It's also worth addressing the idea that speed bumps damage cars. At appropriate speeds, properly designed speed bumps should not harm vehicles. Modern suspension systems are built to handle vertical loads far greater than those produced by low-speed bumps. Damage usually occurs when drivers hit them too fast, or when poorly designed bumps are installed without proper standards. In those cases, the problem is not the concept, but the execution. Emergency vehicles are often brought up as a concern, and that's one reason speed bumps are avoided on primary routes. In areas where emergency access is critical, designers may choose speed humps or tables instead, which slow regular traffic, but allow longer wheelbase vehicles to pass more smoothly. Again, this is not accidental. It's part of balancing safety with access. There's also a psychological component at work. Speed bumps create anticipation. Once you know they're there, you begin adjusting your speed before reaching them. Over time, they train drivers to expect slower environments. This conditioning effect persists even when the bump isn't immediately visible. Drivers become more cautious simply because the road feels different. Interestingly, this is why removing speed bumps after installation often causes speeds to rebound quickly. Without the physical feedback, drivers revert to previous habits. The bump wasn't just slowing traffic at one point, it was shaping behavior across the entire space. Speed bumps are also a response to the limits of signage. Many drivers tune out signs after repeated exposure. Speed limits, warnings, and painted messages lose effectiveness over time. Physical infrastructure does not. It cannot be ignored or scrolled past. It demands engagement whether you like it or not. From a systems perspective, speed bumps represent a design philosophy that prioritizes outcomes over comfort. They acknowledge that human behavior is imperfect and build safety into the environment itself. Instead of relying on constant enforcement or ideal decision-making, they embed constraints directly into the physical world. This approach is common in many engineered systems. Elevators are designed to stop rather than fall. Automatic doors default to opening instead of closing on people. Fire sprinklers activate locally instead of flooding entire buildings. Speed bumps fit into this same category. They are uncomfortable by design because discomfort is the signal that something matters. It's also important to note that speed bumps are not intended to be universal solutions. They are one tool among many. In some places, road narrowing, raised intersections, visual cues, or curb extensions may be more appropriate. Engineers choose speed bumps when they need a strong, immediate, and reliable reduction in speed. When people say speed bumps feel aggressive, they're usually right. But that aggressiveness is calibrated, measured, and purposeful. It's not random. It's not punishment. It's a physical reminder that the space you're driving through prioritizes safety over convenience. So the next time you feel your car jolt over a speed bump, that reaction isn't a design failure. It's the system working exactly as intended. It didn't slow you down because it was polite. It slowed you down because it had to. And in environments where even small mistakes can have serious consequences, that kind of design isn't overkill. It's deliberate. If you like understanding why everyday systems work the way they do, you might want to subscribe. That's what this channel is about.